All right, so what we're going to do now is we're going to continue with solving for some number that's on the interval of the range of a uniform probability distribution. Okay, but now in the last video we did x is x is less than a, and in this video we're going to do all examples where x is greater than a. So you have to be very careful if you're looking at some test problems or homework problems. Make sure you're being very careful to look at this symbol. And if you still struggle with the subject of less than versus greater than, then my hope is that you can figure that out. That there are ways of being able to distinguish between those symbols. Okay, so again, we got a random variable x that's best described by a uniform probability distribution. The range is from 5 up to 16, and so automatically that makes our probability density function 1 over whatever 16 minus 5 is, and 16 minus 5 is 11. So our probability density function is 1 over 11. Now we want to find the value of a that makes this statement true. Okay, that when x is greater than whatever that number is, then the probability is 0.53. Okay, and so just to give you a quick picture of what that's going to look like, we're going to have a rectangle that runs along the x-axis, and at the bottom of the rectangle is 5, which is our low end of the range, and the number up here is going to be 16. And the height of this rectangle is going to be 1/11th, because that's our density function. And so what we're looking for is a number somewhere along here, somewhere between 5 and 16, and we're going to call it a. Okay, but this time in the last questions we did, it was when x is less than a, it equals our proportion. Okay, but now we're looking for when x is greater than a. So we're looking for a region right here. We're looking for a number a such that all of the region between a and 16 is equal to, has a probability of 0.53. And so if this is 0.53, then over here is 0.47. So there's a couple ways of doing this. You can either do that a up to 5 is 0.47, or I'm going to show you the way that you can just do it where between a and 16 is 0.53. But either one will work. Okay. In fact, maybe we'll do both of them just so that you can see that they both work. Okay. All right. So let's get rid of this and let's see how Mr. Ryan would address this this particular question. Well, we know that 1 over 11 times, now that we're doing x is greater than a, what we're going to do is we're going to do 16, we're going to do 16 minus a. When we do less than, we do a minus 5. But when we do greater than, we always do the larger number minus a. We know that a is a number somewhere between 5 and 16, so it's less than 16. So we're going to do 16 minus a. And that's going to be equal to our probability, or our proportion, 0.53. Okay? And now we're going to start off solving this the same way we did in the last video. We're going to multiply by 11 so that we can cancel the fraction. So that means we have to multiply by 11 over here. So 0.53 times 11. So we're going to do 0.53 times 11. And that's going to give us 5.83. So what we have here is 16 minus a equals, what was that? 5.83. Equals 5.83. Okay, and so we just got to do a little bit of algebra here, because this a is negative and we don't want a to be negative. So one way of doing that is just simply to add a to both sides, add a, and now we have 16 equals 5.83 plus a, and now we'll subtract 5.83 from both sides. 5.83 from both sides. Over here it's going to cancel, And we're going to wind up with A is equal to whatever 16 minus 5.83 is. So 16, whoops, that's 16 minus 5.83, and that's going to give us 10.17. So our final answer is 10.17. Now, I said there's another way we could do this, okay? Basically, the way we do it is we change this into x is less than a, so, and we already know how to do this one from the last video, is equal to 1 minus 0.53, which is 0.47, okay? And so now the way we did these in the last video was we did 1/11 times a minus 5, whatever the lower end is equal to 0.47. Then we multiplied by 11 on both sides, multiply by 11, and that's going to cancel the 1/11 over here. And now we want to do 0.47 times 11. 0.47 times 11. That's going to give us 5.17. So this is going to be a minus 5 equals 5.17. Then we add 5 to both sides, and we get a is equal to 10.17, which is the same thing that we got over here, okay? And so these are both ways that will get you to the right answer, and you just have to decide which one you like using the most, okay? Let's try another question. All right, look at this one. Suppose a random variable x is best described by a uniform probability distribution. The range goes from 51 up to 98. And so 98 minus 51, that's 47. So our probability density function is going to be 1 over 47. Okay, that's pretty easy. And now we want to find the value of a that makes this statement true, and it's an x greater than. And so we can either do it as x greater than a is 0.27, but another way we could do it is we could do it as x less than or equal to a, that's ugly, less than or equal to a is equal to 1 minus 0.27, which is 0.73. So we can do it this way if we like that way, or we could do it this way. I'm going to do it this way, okay? So I'm going to take my 1 over 47 times my larger number, 98 minus a is equal to my probability, 0.27. Now I'm going to start off by multiplying by 47. So 47 on both sides, 47, okay? Over here it's going to cancel, and I'm going to do 0.27 times 47. Okay, so 0.27 times 47, and that gives me 12.69. So equals 12.69, and over here we have 98 minus a. 98 minus a. Okay, I'm going to add a to both sides to make the a positive. It'll cancel here. Now I have 98 is equal to 12.69 plus a. Then I'm going to subtract 12.69 from both sides. 12.69 on the right side, it's going to cancel. And I'm going to have a, whoops, that's equal sign didn't work out well, equals a. And 98 minus 12.69, 98 minus 12.69 gives me 85.31. So 85.31. And now if you want to be the person who says, well, I prefer to do it the other way, let's go ahead and do it the other way. So again, we're going to have 1 over 47, oops, 47, 1 over 47, times, now it's going to be a minus 51. A minus 51 equals 0.73. 73. And we're going to multiply by 47 on both sides. It's going to cancel. Multiply by 47 over here. We're going to get a minus 51 equals whatever 0.73 times 47 is. 0.73 times 47. And that's going to give us 3431. 3431. Now we're going to add 51 to both sides and be done. Cancel. We have A equals 51 plus 3431. 51 plus 3431. That gives us 85.31, which is the same answer we got in the other way that we did it. Okay, so these are both different ways that you can solve this kind of uniform probability distribution problem.